This is published by Gronveld at the Solid State Circuits Conference in 1989. All right, so let's say that we have a sea of current sources that are produced by MOS transistors that are supposed to be identical. Like this. They come up into a switch matrix here that can connect them to ground or connect them to the output bus. Now, normally what you would do is you would connect all these gates together. And what you'd be hoping is that you have perfect matching on the transistors so that all these currents are equal. So let's say we want all these currents to be equal to I. But the problem is that what happens in practice is mismatch among the transistors causes the currents to be different if all the gate voltages are identical. So what we're going to do is connect the gates independently to whatever voltage is required at each gate to make sure that all the currents are equal, even if we have mismatch. And we'll show that here by putting a capacitor on each one of these gates. We're going to store just the right voltage on each capacitor so that every transistor gives us a drain current of I. Okay? So how do you do that? So to calibrate each current source, you use negative feedback. The basic idea is that you have a current source, let's call it Iref, that you'd like to use to program the other current sources. So you take one of those current sources and you put it into negative feedback. So you have a switch that's closed, like that. This becomes a negative feedback loop, and you store the voltage that you get on the gate on this extra capacitor. So let's show in here that this is a negative feedback loop. So if the current flowing down the drain of the transistor isn't equal to Iref, then you'll change the gate voltage until the current flowing down here equals Iref. All right, then eventually you're going to open this switch. When you open the switch, you hope that you don't disturb this voltage, so you leave it exactly where it needs to be so that the current that's flowing down here continues to be Iref. Okay? So let's talk about some problems with this situation, and then solutions to those problems. All right, the first problem here is that when you're calibrating a given current source, you can't use it to contribute to the DAC output. So during calibration, of a current source, CS is current source, this current source cannot be used to contribute to the DAC output. And that's because it's busy. It's busy getting programmed to this value. So the solution to this is that you need to have an extra current source so that at any given time, one of them can be calibrated, like this one, while the other ones, which have already been calibrated, can be used to contribute to the output. So the solution here is you need an extra current source. So for example, if you're building a 6-bit DAC, you would expect to need 63 current sources. All right, but I'm saying that you would really need 64 in practice. You expect 63 because 2 to the 6th is 64. You expect that full scale is 1 LSB less than whatever the full scale current is. So you expect that 63 current sources are what you need, but you really need one more, 64 current sources, so that at any given time, one of them is being calibrated while the others could be contributing to the output. Any questions about that?